Hello everyone, I hope you are all doing great. So today we are going to start with the second part of our topic of nomenclature. We have two different systems that we are going to cover. The first one is the systematic, the one that we have seen already, the one that classifies the compounds into three different types, type 1, 2, and 3. And then what we are going to see today is traditional nomenclature. So it's a different system, it works slightly differently, so let's see how it works. So these are the three key ideas for traditional nomenclature. The first difference from the systematic one is that in this case, all the compounds are treated the same way. So we don't have to classify type 1, 2, 3. No, we don't need to do that. We don't have to classify it into metals and non-metals. All the compounds are treated exactly the same way with exactly the same process and rules and steps. The only criteria that we are going to use is the amount of oxidation states that our element has. What element, as we did in the previous system, we all focus in the first element in the formula. So it's usually the metal, so that's the element. The first element in the formula, that's the one that we are going to focus on in order to name the compounds. And the third rule, or the third idea that this system has, is that it uses prefixes and suffixes to differentiate between compounds. So hyper, os, ik, per, ik, hypo, ik, and so on and so forth. And in here we have them in Spanish as well. So maybe you have heard of some endings of names like this, also ico, per, ico, so that's where they come from. So let's have a look at an example to see how these work. This is a general overview of the prefixes and suffixes that we are going to use. As it says in here, the only criteria that we are going to use is the amount of oxidation states that the element has. So the way this table is used is here on top, we have how many oxidation states the element has. If it has only one, if it has 2, 3, 4, or 5 oxidation states. And then depending on how big the number is, if we compare the oxidation state of that specific element, then they will choose certain suffix or certain prefix according to it. So let's have a look at an example to clarify this a little bit. On top in here, we have a compound, this one right here. So we don't need to worry too much about classifying it yet. We just need to focus in the first element. We go to the periodic table, we look for the oxidation states, and then we determine how many it has. So let's say I'm using this periodic table, so I look for manganese right here, and according to this periodic table, it has 5 different oxidation states. Okay, so I have to look for the prefixes and suffixes for an element with 5 oxidation states. Okay, that's the key that we need to use in here. We look for the element, and depending on how many oxidation states it has, we will look for prefixes and suffixes. If it's, for example, nickel, okay, it has 2 oxidation states. If it's zinc, it only has 1 oxidation state. So depending on the amount of oxidation state that the element has. So let's go back to these steps. Sorry, to the table. So we have determined that manganese has 5 different oxidation states. So we need to go to the last column that says 5 oxidation states. And then these are the prefixes and suffixes that we are going to need in order to name this compound. Of course, we only need to choose one set of prefixes and suffixes. So for that, we need to determine what are the oxidation states of the elements in this case. So to determine the oxidation state of oxygen, we need to determine whether the compound is an oxide or a peroxide. So as we notice, the oxygen has a subscript of 7, which means this cannot be a peroxide because the subscript for peroxides is always going to be 2. Therefore, this compound is an oxide, and the oxidation state of oxygen as a consequence is going to be -2. Now, what is the oxidation state for manganese if I know that the addition of these numbers here have to be 0. So I have 7 times minus 2 is minus 14, which means if I have a 2 in here, I will need a 7 as well in here. Another way of doing it is doing crisscross backwards. So if I have the 7, this 7 is going to go here, and this 2 is going to go here, which means the oxidation state of my element manganese is 7. Okay, so I will have to do these steps in order to first determine if it's an oxide or a peroxide, and then to determine what is the oxidation state used by the element, because that's going to guide me in choosing the suffixes and prefixes. Okay, so I have found that the oxidation state is 7. Now, if I go back to all the oxidation states of my element, right here, 2, 3, 4, 6, and 7. What I am going to do is organize them ascendingly. So in this case, they are already organized in consequent order. 2, 3, 4, 6, and 7. Why do I need to do that? Because in the table here, I'm going to erase a little bit. Here. Okay, so once again, what I have done, I am going to name, what I'm trying to do is to name this compound with this system. So first step I did, determine oxidation states, and also check in periodic table. I check in the periodic table, and this element has oxidation state 2, 3, 4, 6, and 7. Let me double check if that's correct. 2, 3, 4, 6, and 7. Yes. Okay, so that's what I did. I have my compound. First thing, I go to the periodic table, check the oxidation states. It has a total of 5 different oxidation states, which means this is the column that I'm going to use as a guidance, because my element has 5 oxidation states. I determined the oxidation states of this particular compound and found the manganese is 7, which means it is using the highest oxidation state of all of them. Which means in here I'm using the largest number of all, and therefore I will have to use these last prefixes and suffixes. These are the ones that are going to be needed for +7. I don't have to do this, but I'm going to show you how it's going to work for the other ones, just to show you how it works. So let's say my compound is using 2, so then it's going to be the smallest number of all of them. So the smallest number is going to be on top. These are going to be the prefixes and suffixes in that case. Or if it is using 4, okay, it's the first, second, and the third number. First, second, and third. So this is going to be for 4. This is going to be for 6. And this is going to be for +3. So depending on what is the oxidation state that the element is using, some prefixes and suffixes are going to be used. Okay, so that's how it is used. So if I'm going to name the compound, I'm going to start with the name of the first element as usual. So in this case, it's manganese is the name of the element. However, it says in here that I have to use this prefix and this suffix. So the element is just manganese. If I use the prefixes and suffixes that I'm being told to use, then this is going to be turned into hyper manganic Okay, so that's how we name it in this nomenclature. We look for the name of the element and we add the prefixes and suffixes according to the table. These suffixes and prefixes are only for that first element because if I am using them, I am letting everyone know what is the oxidation state of this element that I'm using. So in this case, it's manganese, what I'm looking for. So manganese is where I add the prefixes and suffixes. And then the second part of the name is just oxide, because we have determined that the compound is an oxide. So the second part of the compound is going to work exactly the same way we have been doing it with other compounds. So the only part that is going to change is the first part of the name. Hypermanganic is telling me that the element is using the highest possible oxidation state. So if I have the name, I will be able to figure out the formula based on the oxidation states. Okay, so that's how it works for manganese. I'm going to give one more example in order to clarify it a little bit more. Okay, so on the other side of our slide, we have right here another compound. Okay, in this case, it's iron. So first step that I can do, it's okay, I go to the periodic table and I look for iron. So iron is right here, and iron has two oxidation states, +2 and +3. That's the information that I need to take into account. So iron +2 and +3. These are all the oxidation states that my element has. So that's what I'm going to use in order to name the compound. Iron 2, oxygen 3. Okay, and then as the element has 1 and 2 oxidation states, I'm going to my table and I look for the column with 2 oxidation states. So there are 1 and 2 possibilities. For the smallest number, in this case 2, I am going to use O's, and for the larger number, I'm going to use +3. Sorry, I'm going to use ig for +3. And this is supposed to be a 3. Okay, so that's how it works. Look for the element, look for the oxidation states, and if you want to write them as write them in here, or if you just want to focus in your compound, up to you. So next, I will have to determine what are the oxidation states in my specific compound. So I was given this compound. Once again, oxygen has a subgroup of 3. That is telling me that my compound is an oxide. So I'm going to write the word in here because that's the final word for my name. And then once again, I can do the crisscross backwards. So oxidation state of oxygen is going to be 2, and I know it's negative, and I know it's 2 also because I know it's an oxide. And then therefore, and as a consequence, iron has to be +3. These two are going to be balanced. 3 times -2 is -6. 2 times +3 is +6. So that's going to be 0, and that's it. So this is the number that I'm going to use in order to determine what is the prefix or suffix that I will need to use. If iron is using +3, it is using the highest oxidation state, the larger oxidation state, +3. So in here, O is going to be for the smallest, and ig is going to be for the largest. So ig is the suffix that I'm going to use. So it's going to be ferric, and then oxide. Okay, so these two go together. Sorry, I wrote them a little bit separated, but that's the name. Ferric oxide, and that's it. So the idea for the rest of the class is that you practice a little bit solving some exercises so we can clarify, and you can practice a little bit. I will be connected the whole time if you need to clarify anything, if you're struggling, if you definitely are not able to solve it, then you can come in the Zoom link and let me know your questions. This is another way of presenting exactly the same information. So have a look at both tables and choose the one that you prefer. Maybe print it and paste it on your notebook because we are going to need it for this topic and even next year because we will continue with nomenclature.